Hi, welcome to this brand new tutorial series where we're gonna make an RPG, specifically either an action RPG or a turn-based RPG, depending on which path you choose at the end of this video. So in this video, we're gonna design our level, make a player that moves and animates, and make enemies that move randomly and follow the player when it's near. Before we get started, I want to tell you the best way to follow this video, which is to watch me code an event, then let me give you an explanation of how the event works so you have an understanding of what's going on. Then you pause the video and go and code the events for yourself. Once you're done coding, you come back to the video, play it, and then follow the same steps for any events after that. And with that out of the way, let's get started. First of all, go and open GameMaker and then click on New and select this RPG tutorial template. So this is a project that already contains all the sprites or images that we're gonna need for this whole series. So select that, then enter a name for your project here and click Let's Go. Your new project will open and the first thing you're gonna notice is the list on the right side, which has all the assets for your project. Now because we have opened a template, this already has a bunch of sprites that we can use. So let me go through the ones that we're gonna use first. This is a lava background for the entire level. This is a tile set that we're gonna use to design our levels. And these are the player sprites. So there are 8 sprites in total, and there are 4 sprites for each state of the player, and there are 2 states, idle and walk. So each state has sprites for when the player is facing up, down, left and right. You can open these sprites, go into edit and change anything, or draw yourself here because GameMaker has its own image editor and you can make your own sprites in here. I'm gonna close this and just use these sprites. Let's click on the objects folder. We'll go up here in this menu and double click on objects to create one. Let's name this obj_player, so obj stands for object. You can rename it with F2 or this menu option. The object's properties are gonna appear on the left in the inspector. Let's give it a sprite by clicking here and then giving it the idle down player sprite. For making our level, we first need a tile set. So click on the tile set folder in the assets list. Then go up here again and double click on tile sets to make a tile set asset. Its editor is gonna open here. We need to select a sprite to use. So let's click here and select the tile set sprite. So the sprite was just an image, but this tile set asset will now allow us to use the specific tiles from this image to design our level. The default size for each tile, 16 by 16, works for us, so we're gonna keep that. Now we're gonna design our level by going into the default room that GameMaker has given us. So double click on that and the room editor will open. First of all, we're gonna set a background. So go into the layers list here and click on the background layer. Then click here to set a sprite and select the lava sprite. It's gonna appear in the room but only once. So to make it repeat and fill the room, we're gonna enable the horizontal tile and vertical tile options. Now in the game, we want this lava background to keep moving. So we're gonna give it a speed of 0.05 in both axes. This value is really low because our game has a low resolution and that's why this needs to be a really small value. Let's make our tile layers now. We'll have 2 tile layers, one for the background tiles and one with the actual collision tiles that the player can't walk through, and that layer is gonna have the walls. So in the layers panel, let's click here to make a tile layer. And let's name this tiles_back. Over on the right side, you're gonna see this. Here you need to select a tile set to use. So let's click here and select the tile set that we made. Now using the individual tiles here, you can design your level. I'm gonna select the grass tile and then use the rectangle tool from up here to quickly design some sections of my level. I'll also take the cave tile and then use that to design a basic cave. Let's make it interesting by designing multiple paths that the player can go through. Now we're gonna make the second layer that's only gonna have the walls. So let's click on this button again and name this new layer tiles_call. So call stands for collision. And these layer names, they don't mean anything specific to GameMaker. It's up to us what we want to name them. And then later we just need to reference this layer name in our game. so the player can check where it's walking to see if there is a tile there or not. Let's go over to the right side and here again select the same tile set. Now you can use these wall tiles from here to design your level and place the correct tiles. But for now, to finish this quickly, I'm just gonna select this one tile and then place the tiles around all the areas where the player can walk. I'm gonna use the line tool for this. The whole purpose of this layer is to make sure that the player can't go out of the tile area and go walking on the lava, so make sure you cover it good. Now let's go to the layers panel again and select the instances layer. This is where you can place your objects and create instances from them, and those instances can then move around and do their own thing. So from the assets list, let's drag obj player and place it here in the grass area in the room. Finally, to finish off our room, let's set up the camera. By default, when you run the game by clicking on this button or pressing F5, you're gonna see the whole room at once. And obviously that's not what you want. You want there to be a camera so that you only see the area surrounding the player. So back in GameMaker, click on the room in your assets so its settings open up in the inspector here. Then go into viewports and cameras, enable the viewports option, then go into viewport 0 and make it visible. So this is the first camera that GameMaker gives us and we are gonna use it. Let's set a width and height for how much area is visible in the room. I'll make this 320 by 180. Then let's set the size of the game window. I'll make this 1280 by 720. Let's now ask the camera to follow the player object by selecting that object here. Then we need to make sure that the player stays in the center of the camera by setting borders that are half the size of the camera. So I'll make this 160 by 90. So that's half the size that we had up here. With this, if you now run the game again by pressing F5, you're gonna see the player in the room and you only see the area surrounding the player and not the whole room anymore. The lava in the background is also moving as we gave it a speed. Now the next thing to do is to code our player so that we can move it with the WASD keys. In the assets list, let's double click on obj player to open it. It will open in the code editor here. By the way, if you're still seeing the old editor, I suggest you go into preferences, then code editor beta and make sure that this is enabled. If you've just enabled it, you will have to restart GameMaker, and then when you open your object, you're gonna see the new editor. So in the player object, we are gonna add two events, create and step. In each event, you can add code, and the code runs when the event runs. So the create event runs only once, and that's where we're gonna initialize any properties that we need to use throughout the game. The step event runs every single frame, so that's where we take the input from the keyboard and move the player. So let's click on add event to add the create event. If you're asked, just select GML code and make sure you enable don't ask again for this project and hit OK. Your event is gonna appear here, and the default text size is gonna be something like this, which is a little small for my taste. So I'm gonna go into the preferences, then into code editor to beta, and then under theme, I'm gonna change the font size to my personal preference, 14. Then just hit OK. With that out of the way, let's go and write our first line of code. This is a variable and we are calling it move_speed. We are setting it equal to 1. So this stores how fast our player can move and we'll be using it in the step event. Let's write this now. Here we are making a variable called tilemap that gets the tile map of the second tile layer that we created, tiles_col. Remember, the player needs to collide with the tiles in that layer because it contains walls. So we are getting its tilemap ID right now so that we can later check for collisions against this layer when the player is trying to move. So now for the movement, we need to add the step event. Let's go up here, click on the plus sign, then go under step and select the step event. The step event will show up here just below the create event. Let's add some code here to check for input from the WASD keys and store them into two variables, one for horizontal input and one for vertical. The first variable here, which is for horizontal input, is subtracting the input of the A key from the input of the D key. That gives us 1 when D is held down and -1 when A is held down. But you're probably wondering, why is it that way? See, the reason we are doing this is because in GameMaker, if you want an instance to move to the right, you add 1 to its x position or its horizontal coordinate, and to move left, you subtract 1. That's why we have these variables set up in this way. Similarly, for the vertical input, what we're gonna do is we're gonna subtract the input from W from the input of S. So that gives us 1 if S is pressed, which helps us move down, and -1 if W is pressed, which helps us move up. Now we know how much to move on both the X and Y axes, so let's actually call a function to help us move. The function we're gonna call is move and collide. A function in GameMaker takes parameters that determine how the function is going to work. For the move and collide function, it takes 3 main parameters. So that's how much to move on the x-axis, which is horizontal, how much to move on the y-axis, which is vertical, and which object or tile map to use as walls so it stops when that is encountered. So let's write this for our code. This calls the move and collide function with the x value being the horizontal input from the keyboard multiplied by the movement speed. Then the y value is the vertical input from the keyboard multiplied by the movement speed again, and then the collision check being the tile map that we stored earlier. So the player is gonna try to move and it'll be stopped by any tiles in the tiles call layer. If you run the game now by pressing F5, you'll be able to move the player in any direction using the WASD keys. But now the problem is that it's using the same sprite for all directions. But you know we have 8 sprites to use for this, so now we're gonna implement that. We're gonna do this using conditions. A condition lets you run some code only if that condition is true. The way we're gonna do it is this. If the player is moving, then we check the input. Based on the input, we set a walking sprite. Else, if the player is not moving, then we set an idle sprite depending on which walking sprite was being used. So let's add this code. First of all, we have a grouped condition that checks if the horizontal input is not 0 or the vertical input is not 0. This means that if either of these conditions is true, the code after it will run. And overall, this grouped condition means that there is input and the player is moving. So let's make a block for this. Any lines that you have inside this block are going to run when the condition is true. In the block, let's add another condition. This checks if the vertical input is greater than 0, meaning we are moving down. So in that case, we'll set the sprite to the walk down sprite. This way we're gonna add 3 more conditions for the 3 other directions. So else if vertical is smaller than 0, it means we are moving up and we use the walk up sprite. Else if horizontal is greater than 0, we are walking right, so we use that sprite. Else if horizontal is smaller than 0, then we are walking left, so we use that sprite. So it's all simple logic. It might be a little intimidating if you're new to coding, but just think of it as talking to the computer, asking it, hey, is this variable this value? And then telling it what to do in that case. So take some time to read this code and make sure you understand what is happening. Now let's add another else block here. This will run if the condition up here is false. So if this block means that the player is moving, this block means that the player is not moving. So here we're gonna set an idle sprite based on the walking sprite that was being used. Let's add a condition to check if the current sprite is equal to the walk right sprite. In that case, we set the sprite to the idle right sprite. So using the same logic, let's add 3 more conditions. Let's check if the sprite is walk left, then set it to idle left. If it's walk up, we set it to idle up. And if it's walk down, we set it to idle down. Again, this might be a lot if you're new, but if you stop to look at it and try to understand the logic, it's actually pretty straightforward. Also, if you're wondering why we've used 2 equal signs here but 1 here, it's because you use 2 equal signs when comparing 2 values in an if condition, but you use 1 equal sign when setting the value of a variable. So now run the game by pressing F5 and you're gonna see that the player moves and animates with the correct sprite for where it's moving and whether it's moving. Now there is a quick fix I want to apply. If you slide along a wall, you can see that the movement gets a little jittery. So to fix that, we need to apply limits to how much the player can move in any given frame. So let's go to the step event and go to this move and collide call, and we're gonna add some more parameters. We want the next 3 parameters to use their default value, so I'll just enter undefined 3 times. And now we have come to the parameters that we actually want to set. So the first one is the horizontal limit. I'll set that to move speed. And then we have the vertical limit, which I'll also make the move speed. So in total for this function, we have the first 3 parameters that we entered before. Then we have undefined 3 times, and then we have move speed twice. If you run the game now and try to slide along the walls, you'll see it's now very smooth. Now we are in the second half of the video and we're gonna add enemies to our game. They're gonna move around randomly in a rectangle surrounding where they were created, and they're gonna follow the player when it's near. Our game's gonna have 2 types of enemies, so we want a way to give both of them the same code from the same place. We're gonna do that through parenting. There will be a main object called obj_enemy_parent. This will have all the code for how enemies move and behave. Then we're gonna make objects called obj_enemy_1 and obj_enemy_2. These will be children of the main object. This way they will use the code from their parent. If the parent has any properties like how much damage an enemy does, then these child objects can have their own values for those properties so that the child objects are unique. They would still use the same code, just their variables would have different values. So let's make an object and call this obj_enemy_parent. Then let's make an object called obj_enemy_1. This will be our first enemy and we'll make the second enemy in a later video. While you have your obj_enemy_1 open, go here in the inspector and click here to give it a sprite. Make sure it's the enemy1 sprite. Then go down here and open the parent menu. From here we need to set a parent, so click here, then select obj_enemy_parent. So it knows that it's a child of that object. Let's open the room now and place some enemies here. In the layers panel, make sure the instances layer is selected, and then from the assets list, drag and drop some enemy instances into the room. Now let's code our enemy so it walks around and follows the player when it's near. Let's double click on obj_enemy_parent. Before adding any events, let's set up some properties. So go into the inspector on the left, and at the bottom, let's click on add variable to add our first variable to this object. The first variable will be HP, which is the amount of health that this enemy has. I'll set this to 3. Then let's create another variable called damage. This is how much damage it does to the player. I'll set it to 1. Then let's create a variable called distance to player. This is how far the player has to be for the enemy to start following the player. So let's set it to 80, which would be in pixels. So that's 80 pixels. Then let's make a variable called move speed, which is how fast this enemy moves. Now it's time to code our events. First of all, I'm gonna go and add the create event to initialize some properties. Let's add this code here. These are the target coordinates that the enemy is going to follow. So it's the target X and target Y. Right now it's set to the same coordinates as the enemy. Then we are setting alarm 0 to 60. There's an event called alarm 0. So what this means is that the alarm 0 event will run 60 frames after this line is called. And by default, 60 frames is 1 second. What we want is for alarm 0 to run every second, and every second the enemy sets a new target position for it to move towards. So we are gonna work on that as well. For now we need another line in this event. We are getting the tile map of the tiles called layer again, which we did in the player as well, so that the enemy can also check for collisions against the walls. Now let's program the alarm 0 event where we're gonna set a new target position for the enemy. I'll click on the plus sign here, and under alarm, I'll select the alarm 0 event. Here we want to do this. First of all, we're gonna check if the player exists and if the player is close enough. If so, we'll set the target position to the player's position so the enemy follows the player. Else, if that is not true, meaning that the player either doesn't exist or the player is not close enough, then we're going to set the target position to a random point in a square area around the enemy. So let's write the conditions for the first check. If the player exists and if the distance to obj player is less than distance to player, we're gonna set the target x and target y values to the player's x and y values. Then we add an else block, and here I'll first of all set the target x variable to a random value between two numbers. The first number is the starting x position of the enemy, minus 100. The second number is the starting x position of the enemy, plus 100. So the target x will be anywhere between these 2 points using the position that the enemy started at. Then we're gonna do the same for the target y position, but using the y start position of the enemy. Finally, we need to set alarm 0 again so that it runs again after 1 second, and this forms a loop so that alarm 0 keeps running every second. Now we want to allow the enemy to move towards the target, which we'll do in the step event, so I'll go and add that. Here let's figure out how much we need to move horizontally and vertically by adding this. For the horizontal value, I'll take the difference between the target x and the current x, and then to make sure that it doesn't go above 1 or below minus 1, I'll clamp it to the range between those values. So it'll be between minus 1 and 1. Then I'll do the same for vertical, but using the target y and current y values. Finally, we'll call the move and collide function with the horizontal and vertical values multiplied with the move speed. It should also stop when it collides with the tile map. Now run the game with F5. You will see the enemies moving about randomly, and when you get close enough, they start following you. Once you get multiple enemies to follow you, you'll notice that they all end up overlapping each other, and it just looks like it's one enemy, so we need to fix that. To fix this, we're gonna modify the move and collide function so it also collides with other enemy instances. For that, I'll first of all make this parameter an array by adding square brackets. An array is just a value that contains multiple values. So I'll add a second value into this array, which is the obj enemy parent object. Now this function is going to make the enemy stop when it collides with either the tile map or any other enemy instance. So run the game and get multiple enemies to follow you. You'll see that they don't overlap anymore and they stay in their own place. The final thing we'll do for this video is to make sure that the order in which our instances are drawn follows the vertical positions of the instances. For example, if the player is below the enemy, it should be drawn in front of it, but if it's above the enemy, then it should be drawn behind it, otherwise you know it's not going to look correct. For that, let's open the obj player object. I'm gonna go to add a new event, and under step, I'll select the end step event. This is the same as the step event, but it just runs after the main step event. So it will run after every instance has run its step event and has moved to its new position. Here we're gonna make a with all block. What this means is that anything inside this block is going to run for all instances in the room. So that's the player and all enemies and everything else. So in this block, let's set the depth variable to negative bbox underscore bottom. The bbox bottom value is the vertical position of the instance at its bottom edge. So we want to use that to sort the instances. It's set to negative because a lower depth means the instance is drawn on top. So if you are below another instance, meaning your vertical position is greater, your depth is going to be that much lower, so you are drawn above that other instance. If you now run the game and walk around an enemy, you'll notice how the drawing order is switching correctly, and it now looks the way it should compared to how it looked before without the depth code that we just added. And that's it for this video. You now have a working player that moves and animates, and enemies that move randomly and follow the player when it's near. We're now gonna move on to combat, which can either be real-time sword combat or turn-based combat. So click on the video that you want to follow, and we'll continue with the game in the next video.